Hello everyone, this is Kikoto Mane from Team Get Wreck Robotics, as well as a member of Team WPI. Today, we're going to be doing something a little bit different from my usual videos. Welcome to the build process, a new video series I'm doing where I build a combat robot and go over the entire process from beginning to end. For our first episode, I'll be redesigning my 150-gram Fairyweight bot, Flak-E-Boi. A lot of you probably know me for my 3-pound beetle weight named Serial Killer. However, what some of you may not know is that Serial Killer was not my first cereal box fiend robot. Serial Killer was actually built to be a scaled up version of Flak-E-Boi, a 150-gram bot that I built a few years back. Back in 2020, I was inspired by an ant weight called the Crave Monster, a well-designed control bot built out of a cereal box. I loved that bot so much that I decided to make my own version for the Fairyweight class. I built the bot using a Frosted Flake cereal box, a dustpan from a broom, Lego wheels, and very basic Antway electronics, with everything being held together with either super glue or tape. I named it Flak-E-Boi, and funny enough, it is now my oldest bot that's still active and has been fighting for the past 4 years. Even though it was not designed to be competitive, Flak-E-Boi has had some small moments of success every now and then, even managing to get 3rd place at a Fairyweight event in Atlanta last year. However, after being mostly on chains for years, I think it's finally time to give this bot an update using the improved building skills I've learned since I first built it. All right, so we got the cereal box. The reason we got that first before doing anything else is just so that we can gauge a general idea of the dimensions of the box, so we can know how the dimensions of everything else should be in reference to the cereal box in the CAD of the robot when we're designing it. So I got this ruler here. So let's see this. The box seems to be almost 7.5 inches wide, about 12-ish inches long, and almost 2 inches tall. And so just using those general dimensions, we can make a 3D model of the box in CAD and then work from there. All right, so here's the CAD for the cereal box. It's a rectangle. It's literally just a rectangle. That's all it is. It's a rectangle. All right, so here is the full CAD for the new Flak-E-Boi. He looks kind of derpy, but I like that. So just gonna go over the general stuff in no real order. So opening up, here are the top panels. The insides are pretty simple. We just have some N20s. Here they just face mount. No, not face mount. They're not face mount at all. They just fit right into these squares. I thought about face mounting them, but I didn't think it was worth the effort, because what I'm going to do is I'm just going to slot them in here and just super glue them into these TPU mounts. Oh, by the way, pretty much everything here is TPU. I use TPU for a lot of things. So yeah, that's what the, and same thing goes for here. So yeah, just direct drive, just some N20 motors directly attached to the wheels. You see some screw holes to screw the top panels on. I haven't put in the other electronics like the battery and ESC or whatever, but I kind of already know they're gonna fit, so I just was kind of lazy, so I didn't really put them there. Anyways, I did put the servo, of course. This is where the servo goes. It just slots right in there. That's also going to be just super glued in there. You see this hole right here? That's mostly just so that I can have wires go in from each side. So, you know, that's what that's all about. In fact, actually, we can take a better look at this entire piece by itself. So this is just one piece. It's the majority of the bot. It's a big dustpan. We have the mount for the motors and the servo and everything. So let's see. So in terms of dimensions, it's about, so I do this right, it's about 8 inches long, 8 inches wide is what I meant. And yeah, just meant to be a wide boy, because, you know, the wider your robot is, the harder it is to get to the side, and makes it easier to like corral bots and so on. You can see we've cut up the cereal box to fit better. It's been hollowed out. So of course, the main idea of this is to just open and close the jaw, to just clamp on opponents with the cereal box so that they can't escape. So this attachment, so this looks kind of weird, but essentially it's just the TPU part that attaches to the servo horn that gets onto the cereal box. That's how we attach the cereal box. We just super glue on here. I have a bunch of sketches here. For some reason, I'm just going to quickly hide this because it's kind of like a mess. But yeah, closer look. So yeah, the I don't know what to call this, but yeah, this is basically just the TPU part that connects the servo to the cereal box. You see, it just slots right in there. Again, I'm just going to super glue that. The thing about Fairyweights is you can kind of just super glue a lot of things and it works out. I'm going to super glue the box to this end of it. But yeah, so again, it's a very simple design. There really isn't a lot of complex stuff. But yeah, just open and close. Oh yeah, I have it. Oh yeah, so when you're doing CAD, so that reminds me. So I'm messing up when talking. This video is not scripted. I'm kind of just going, as is. So I did create this representation of the floor. As you can see, most of the bot in the back is off the ground, and it's just the very lip of the dustpan that rides the ground. Yeah, so just fixing this so you can properly see how the mouth just opens and closes. And I'm pretty sure I've designed the bot so that it can self-write. That's always important. Just double checking. But yeah, I'm pretty sure if it was upside down, it could self-write. And that's mostly it. Like I said, this is probably the simplest bot I've ever made. It's very simple. Almost anyone can make something like this. Just a very basic design. And of course, I have the googly eyes there because, the googly eyes make everything better. That's just how it is. Bots with googly eyes are the best. So yeah, that's the CAD for the new version of Flak-E-Boi. He's a weird little guy, but I love him. All right, now let's go over some of the electronics we'll be using for the robot. Here is the receiver. It's just a 6-channel Hobby King receiver. As you can see, I've already taken off the case to save weight, and I've wrapped in electrical tape. So that's what we'll be using. For the weapon arm, we'll be using this servo. It's a very simple servo you can get off Amazon. I've used it in bots before, especially Fairyweights. And yeah, this should get the job done. Then we have this dual bus drive ESC. Nothing too special here. All I need to do is just solder the drive motors onto these ends. I'm going to cut off these little plug-in things. I don't need them. I'm just going to solder the wires directly to there, and that'll be it. So that's that. Now, for the first time, I've actually gotten some stuff from Turnabot. Turnabot sells really good robot parts, especially for Fairyweights. They sell Fairyweight kits. And yeah, I've started buying stuff from them, and I really like their products so far. First off, we have this 2S LiPo battery. For Fairyweights, you definitely don't need a big battery, and especially since there's nothing too complicated here, it's just a servo and drive motors. This battery should be perfect. Very small, condensed, very lightweight, and excited to use this. Then we have the drive motors. These are some N10 motors, not N20s. They're N10 motors. Again, very small, but they pack a lot of power, and they should give the rod some good pushing power. So there's that. And lastly, we have these wheels. They're actually very similar to Lego wheels, like the rubber on them. And you can see this 3D printed hub. It will just directly press onto the N10 motors. And we put a little bit of super glue on there, and then we're good. And that's pretty much it. That's pretty much all we need, ignoring the serial box and TPU parts we're going to print later. So yeah, let's get to it. Now, probably the biggest limiting factor in making a robot is the weight limit. You have a certain amount of weight to use, and it especially matters in Fairyweight since you only have 150 grams to play with. So before we do anything else, we're gonna just weigh everything we have now to see where we go further. So here's my scale. We have it in grams. And now we're gonna start weighing stuff. So first off, we're actually gonna weigh the cereal box. As you can see, I've cut it down to size. And I've, I got it the way I need it to. So I'm gonna just set that here, 22 grams. So that's the thing right there. So cardboard is a lot heavier than you'd think. I especially learned this on Serial Killer, but you may think it's not that much, but it adds up. So you gotta be very wary of that. And of course, the most important thing, the googly eyes we're gonna put on. So we gotta weigh that too, about 2 grams there. Now we have the servo, the wheels, the motors, the receiver, the ESC. Now, admittedly, I feel like a lot of the ESC is gonna be cut off for weight, like the wires and especially the plugs on the end, but for now, that's what it weighs so far. And lastly, the battery. Okay, so we're at about 90 grams. I think my scale is reasonably accurate. I don't think I've had much issues with it. So I think this is about where it is, which means, assuming it's accurate, we have about 60 grams left for everything else. And the reason I decided to weigh this now is because, so these are parts that we have to have. They can't really change in weight for the most part. But the TPU stuff, that can change in weight. So essentially, I'm going to mess around with the settings on my printer, and I'm going to see what kind of infill and wall count I can do for the TPU stuff, and just mess with that to get it to weigh around 50 grams, give or take, so that it matches up with the weight limit. So let's get back into the CAD and see how much we can get everything else to weigh. Okay, so here we are in Cura. Cura is a 3D printing software that you use to 3D print things and preview them and change how you want to print them and so on. We have our 2 parts here. We have the weapon arm and, of course, the main body that includes a dustpan where everything just fits together. So as you can see, we have settings for generic TPU. Specifically, I'm using Overture TPU. My 3D print has 0.4 millimeter nozzle, so that's what's here. Looking more at some of the settings, gonna just go over this real quickly. We're doing a wall thickness of 1 millimeter, so 1 millimeter walls, and an infill density of about 10%, and we're doing an infill pattern of gyroid. Here's some other stuff we don't really need to get into, but that's the gist of it. Anyways, so as you can already see, it will take about 6 hours and 50 minutes to print everything, and it will come out at 52 grams. Like we said earlier, we're aiming for 60, so this is good. Now we have some leeway in case anything doesn't go exactly right. We have an extra 8 grams to play with just in case. But yeah, this seems to be within weight. And you can see in the preview here, here's the support structure and so on. And yeah, all you need to do now is just save it to the disk, put that disk into 3D printer and start 3D printing. So let's get into that. Okay, I just got back from work after leaving the printer on, and it's almost done. There's about 20 minutes left on the print, and it's looking pretty good so far. So this is my 3D printer. It's an Ender Max Neo. It's not like the best thing out there, but it gets the job done. And I haven't had any real issues with it. Here's my roll of filament. It's Overture TPU. I've used the exact TPU in all my other bots. And yeah, everything looks fine so far. So yeah, you can just look at it go. It's doing its little thing. And yeah, so far things are looking good. All right, so I'm happy to say the parts have officially finished printing. Let's take a look at them now. Here's the weapon arm. Looks pretty nice. And here's the main body and dustpan, which also looks pretty nice. Everything came out about how I wanted, no real mistakes or anything. And yeah, I guess now we can get to placing the parts in here and get to building the robot. All right, so before we do anything else, we're gonna just quickly go over our electronic setup again. As you can see, we have the N10 motors just soldered onto the wire leads for the dual brushed ESC, which just plugs right into the receiver. The weapon servo is also just plugged directly into the receiver. And of course, the battery plugs into the ESC, which sends power through everything else. So yeah, as you can see, it's a very, very simple setup. Probably the simplest setup I've ever done for a robot. And let's just quickly test, make sure everything works. So first, the weapon servo. Yep, the servo's totally fine. That's good. Now the drive motors. The drive motors are turning. And yeah, everything seems all right. The drive motors work. The servo works. And yeah, the electronics, everything seems fine. So let's get into the next step. All right, so I've put the electronics and everything into the main body of the robot. As you can see, I've attached the servo arm to the servo. The servo is put into its mount. The N10 motors are put into their mounts. The wheels have been attached. And I've just put all the electronics in there. It's kind of just taped in there right now. I didn't really take into account top armor or the size of the electronics, so it looks kind of awkward, but that's just how it is for now. And yeah, it looks about how I imagined it. A little closer look at everything together. You see all of that. And yeah, the final and most important step is to add the cereal box. And here we go. The cereal box has been attached. As you can see, it's super glued down. I put some clear tape on there. And yeah, it is a cereal box attached to the rest of the robot, just like I said. Nothing much to say from there. Good old cereal box. And now we're gonna drive this. We're gonna do a test drive and just make sure everything works as intended and go from there. All right, first weapon and drive test for the new Flak-E-Boi. So first we're gonna test the servo. Oh, okay, he just flipped himself over. So that isn't very good. Let's see if we can self-right. There's a good test. No, we cannot. So that is concerning immediately. Let's just flip him over. Okay, he's trying his best. Okay, this could be going better. We're gonna do some driving. The robot does drive, so yeah, that is good. Not very smoothly, so I'm not entirely sure what the problem is. We might need to mess with trim. Also, as you can see, when I lifted the cereal box, the robot just flipped itself over, which is bad. So we're gonna try to do something to stabilize it. Maybe add some kind of tail on the end. But that's okay, you know, gotta do problem solving. So let's get back into it. All right, so in order to hopefully stop the bot from flipping itself over, I have attached this spoon to the robot as some sort of makeshift tail. I have no idea if it's actually gonna work, but you know, it's worth a try, and at least it's thematically appropriate. So let's do another test. All right, let's do another test and hopefully see if the spoon can solve all our problems. Okay. The robot seems to be driving better. You see the spoon resting against the ground so it doesn't wheelie. Close, open. Close, open. There's the mouth. And yeah, it's driving okay. These motors are really fast. I gotta get used to driving it, but things seem to be working a lot better than before. So I'm really happy with that. All right, so the bot is almost done, but there's one last thing we gotta do, and it's always the most important thing. We gotta give it some personality. And I'm gonna do it very simply by doing this. All right, there's one googly eye. And there's two googly eyes. So yeah, the robot now has personality. That was the most important step, and we did it. And now the bot is mostly done. We're gonna put on the scale and just see how much it weighs. But yeah, looking good so far. All right, so let's just make sure we're still in the weight limit. Hopefully we're not overweight. Let's just put a Flak-E-Boi on the scale. And, oh, we're good. We're actually about 12 grams underweight. That's impressive. So there does seem more stuff that I can add. I'm not really sure what I'm going to do for now, but I'll see. But yeah, for now, the bot is well within weight, and everything seems good to go. Overall, I'm pretty happy with how Flak-E-Boi turned out. The bot definitely isn't perfect, but I'm okay with that. Something I forgot to mention is that this version of Flak-E-Boi will fight in the Sportsman Fairyweight class at T-Town Beatdown on August 3rd. Since it's a Sportsman class, that means it's mostly just going to be other control bots, and there aren't going to be any damaging weapons like spinners, so hopefully this means I'll be able to get away with making a bot out of cardboard, tape, and super glue. The bot isn't the most durable, as you can tell. Regardless, Flak-E-Boi isn't meant to be that competitive anyways, and as long as I can put on some fun fights for the audience to enjoy, I'll be happy. And that concludes this first episode of the build process. Like I said, this is a new type of video series I'm trying out, and I hope you guys enjoyed it. Feel free to let me know what you thought in the comments, and thanks for watching. Have a wonderful day.